Okay, in this example we have to obtain the impulse response of a capacitor and use it to find its unit step response by means of convolution integral, and let C is equal to 1 farad, means the capacitance of the capacitor is 1 farad, and here our system is a capacitor. It is a very simple circuit that consists of a capacitor, and we have to find out first its impulse response, second its unit step response by means of convolution integral. You know that impulse response is very important in order to find out the output of a system, because the output of a system is equal to the convolution of input and its impulse response. So first we find out impulse response of the capacitor, and second we find unit step response, means that the output of the capacitor when the input looks like a unit step function, or the input is a unit step function. We will do that by means of convolution integral, and while doing so we will use the value of the capacitance as 1 farad. So first we know that the output of a capacitor can be represented like this. Vc is the output voltage and Yt is actually the general representation of output of a system. You can look back in the slides of magnitude and phase spectra, where we solved a problem related with an RC that involved an RC circuit. We used similar equation there for the current across the capacitor. Okay, so this is the output voltage across the capacitor, this is the input current, and this is the capacitance. So you also know that in order to find out the impulse response, our input must be a delta function. Therefore the current input must have the form of a delta function. So for impulse response, the input must be a delta function, means I current must be of the delta function form. How delta function looks like? It looks like this. It is 1, it has a magnitude of 1 at 0 and 0 for all of the rest of the signal. So we can write this equation like this. V, the output, or Yt, the output, is represented as H because it is the impulse response, and impulse response is represented with Ht. Therefore the output is Ht and the input is delta function. Okay, now we can perform the integration over it. So the integration of the delta function will be 1. Okay, because it is from 0 to t, we consider it just before the 0 and go on, because 0 is 1 and rest of the signal is 0, so the total integration will be equal to 1. Therefore it can be written like this: 1 over c times 1 for all n is equal to actually it should have been t for t equal and larger than 0. And we also know that C is equal to 1. This is the representation of we can represent a signal like this, 1 over C. This is the signal times this is the unit step function. What unit step function does, it reduces everything below 0 to 0 and everything after 0 equal to its own magnitude, because unit step function is 0 before 0 and 1, it keeps on a steady form of 1 after 0. So this is the general representation of a signal. So we can multiply a signal with ut and it keeps its own form. And for C is equal to 1, means the capacitance was equal to 1 as given in the statement, we can write UHT is equal to UT, means the impulse response is equal to unit step function. Now the output of a function of this function, or sorry, of this system, when the input is the unit step function. Okay, so the output of a system will be calculated by performing convolution between impulse response and the unit step function. So here is the impulse response. This is the convolution integral. You can go back and see how it is represented. Unit step function shifted. This is the shifted unit step function, and this is the this is the shifted impulse response, and this is the input. And we perform integration from minus infinity to plus infinity. The capacitance is constant. We can take it outside, and the impulse response, since it was ut, we can replace it with this one, the shifted unit step function, and c is equal to 1, so it does not matter. After multiplying the whole expression with 1, it will stay the same. Okay, therefore, because c was equal to 1 farad. Next, we can split this integral into two, minus infinity to 0 and 0 to infinity. Why? Because of the unit step function. Unit step function in this region will be equal to 0. Minus infinity until 0, the value of the unit step function is 0, and from 0 until the end of the signal. So instead of infinity, we are using t, because this t will just represent the length of the signal. The signal ends after that. So 0 until t is the duration of the signal after 0. So in this duration, the unit step function has a magnitude of 1. So this part reduces to 0, and this part is 1. This part is equal to 1. Therefore, our VC, or the output, will be equal to t after this integration. When we perform integration, it will be equal to t. So it will be equal to t for all values of t equal and greater than 0, and it will be 0 for all values of time less than 0. This one means that this is the more significant one, because the signal exists only in this region and it is equal to the time. Means that it will be a diagonal straight line increasing linearly. And which function looks like this? That is the ramp function. Therefore, our VC, the output, is a ramp signal. Okay, in this example, let Hn, means the impulse response, is this a discrete sequence, 1, 2, 0, minus 1 and 1, and input Xn is 1, 3, minus 1 and minus 2. This one has 4 points and this one has 5 points. Be two causal sequences. So you have to consider these two sequences which are causal, means that they are starting from 0. The first sample is at 0, 1, 2 and 3. 0, 1, 2, 3 and 4. So Hn represents actually the impulse response and Xn represents input of a system. And both of them are causal sequences. Find out the output sequence Yn and then sketch all of these signals. Now first thing, you should notice that these are discrete time sequences, one thing. Second, you are asked, or you are required to calculate the output sequence Yn. Okay, so you know that the output of a system is actually the convolution of input and the impulse response of that system, right? So we have to do convolution here of x and h. But which one to use, convolution integral or convolution sum? We will use convolution sum because this is discrete. These are discrete time sequences. In the previous example, we used convolution integral because that was a continuous time sequence. Continuous time signal. Now we know that the convolution sum is represented like this, Yn starting from k is equal to 0 until n is the total number of samples in the sequence, h, k is the impulse response, and x and k, s and minus k is the shifted input sequence. Okay, so now let us see how we can compute this convolution sum. First we need to draw a table like this. The top row is the values of k, this k, and you notice that it is starting from -3 until 7. So these values -3 until 7 depends on the number of the input. Here the one that we want to shift, the shifted x or the shifted input sequence. Since x had 4 samples in the sequence, so and we need to flip it in order to obtain this one, n minus k. You remember in the first or second lecture we shifted the sequence, or we plotted a sequence like this, or sorry, a signal like this. At first we need to flip it, means xk will be flipped to get x minus k, and then we keep on adding the value of n, means 1 2 3, that we will be shifting it towards right. So first we get x minus k, which is the flipped version of x. Since x had samples from 0 until 3, 0 1 2 and 3 make 4 samples, so when we flip it, it will go to 0 minus 1 minus 2 and minus 3. That is why 0 minus 1 minus 2 and minus 3. We have extended from minus 1 0 until 0 to minus 1 minus 2 and minus 3, depending on the number of samples in the original input sequence. And then this n, these are the number of samples in the output sequence, which will be calculated from the number of samples in input sequence plus number of samples in output in the impulse response minus 1. So x has 4 samples, h has 5 samples, so total 5 plus 4 is equal to 9, minus 1 makes 8 samples. Therefore the output sequence will have 8 samples, 1 2 3 4 5 6 7 and 8 samples in the output sequence. This one, the last column, will be our output sequence. We will calculate values and keep on adding, keep on filling in these cells here. Okay, let us start first. First we are writing our impulse response, because we were told that actually both were causal sequences, means both are starting the first sample of both of the signals of the sequences x and h will be at 0 sample number. So this is a 0 sample number. H is starting from here, 1 2 0 minus 1 and 1 and 1. This is from the our statement. And then we will write down x. This is x, also starting from sample number 0, then 1, sample number 2 and sample number 3. Okay, now from here onwards, these were the original sequences, those which were given to us in the statement, in the question statement. Now we have to start solving it. First we will achieve x minus k by flipping it, okay, by doing like this. So when we flip it, the sample which was at 1 will go to minus 1 here. This one is at sample position 2, it will go to minus 2, and this one was at sample position 3, it will go to minus 3. So by doing so, we have flipped our x, okay, or you can say that the value of n was 0 here, so 0 minus k will be minus k. You can relate it from here. Okay, for the next sample, this is done to calculate our first sample of yn. Okay, so first we will fill all of this and then we will calculate one by one all the samples one. Okay, for the next sample number second sample or sample number 1 in yn, we will shift this sequence x minus k by 1. How we can shift it? Simply like this. We push all of it, the whole sequence, towards right by one step. Okay, so we have shifted it, the whole sequence, like this. Now for 2, we will shift it one more step. So this is 0, shifted by 0, shifted by 1, shifted by 2, and shifted by 3, and 4, and 5, and 6. So we will keep on writing it like this. So this was x0 minus k, or just x minus k, then x1 minus k, x2 minus k, x3 minus k. This factor is representing the shift, the number of samples it is shifted. Okay, so the last one will be shifted by 8, by 7 actually, means the 8th one is shifted by 7 here. Okay, so first we flipped it, and then we kept pushing it one sample towards the right. Okay, now how to calculate our yn? So we have to multiply the corresponding sequences, corresponding sample numbers in h and x. So you notice that we have to multiply h with x, right? So this is h. Okay, it will stay at the same, because this is the stationary one, it is not moving. This one is moving, this one is moving one step at each iteration. So we'll start multiplying it. In order to multiply that, we'll go to the next slide. Okay, now let us see how we calculate our output sequence. It is already given here, but how we get these values? After laying down all the values here in the table, we need to calculate each sample of yn one by one. So just notice that this row means first, when we start to flip it and then shift it, the first will be will be used for calculating first sample, or sample number 0. This one for sample number 2, sample number 3, 4, 5, and so on. So also notice that we have to multiply h with x, the samples of h with samples of x. So, and we will only multiply the samples on the same position in the sequence. For example, samples on 0 will be multiplied with samples on 0, and samples on 1 will be multiplied with samples on position 1, and so on only. So for the first sample, we will see which of the h and x are on the same position. So only these two, right? So we have two samples which are overlapping, which are at position number 0. So we multiply them together. 1 multiplied with 1, we get 1. This is our first sample. Now to calculate second one, we need to move to the next row and see which samples are overlapping on the same sample positions. So we have two samples overlapping on position 0 and position 1. We will multiply the samples on position number 0. So we get 1 times 3 equals to 3, and this one 2 times 1, 2, and then we add them together. So 3 plus 2, we get 5. Okay, and similarly for the next step, we see which ones are overlapping in this. So 0, 1, and 2, these are overlapping. Okay, after that and before that there is no overlapping, because here we don't have h, and here we don't have any value from x, shifted x or x to minus k. So we multiply overlapping values. 1 times minus 1, we get minus 1. 2 times 3, we get 6, and 0 times 1, we get 0. So 2 times 3, 6, and 1 times minus 1, minus 1, 6, minus 1, we get 5. Right? So similarly, we'll keep on going and multiplying, then adding samples, and we get these values of yn on the output. And that's how we compute our convolution sum to get our output sequence. and now we have to sketch them all one by one. Okay, one more thing that we do, why we do not the empty cells, we do not multiply them, because we assume that all the empty cells are filled with zeros. You remember the concept of padding with zeros, right? So in order to make them full length, means in order to make them of equal length, like from -3 until 7, so we fill our actual sequence with the positions of the samples, and rest of them we fill them with zeros only. So if we multiply them, we will get our answer as 0. That is why we do not multiply. We multiply only the places where the sample signal actually exists. Okay, and this is how we can sketch them all. First is our input sequence. It has 1, 3, -2 and 0. This first one is at 0 sample position. It has a magnitude of 1. So the x-axis is actually the sample number or the sample positions, and y-axis represent the magnitude of that sequence. So each sample has a sample position and its magnitude. First one is at 0. It has a magnitude of 1. Second one is at sample position 1 and it has magnitude of 3. It will go like this. And third one is at sample position 2 with magnitude of -1, and second one is at magnitude of -2. Sorry, the fourth sample at sample position number 3. Excuse me. And similarly we can plot our the impulse response like this, and our output sequence like this. Okay, the third example. In this example we have to find out the convolution of this impulse response and this input sequence when k is equal to -1, 0, 1, 2 and 3. Now notice that our k is starting from -1, not from 0 as in the previous as it was in the previous example. And also note that these are discrete time sequences, and we have to perform convolution. Since they are discrete time, we are going to use convolution sum, and that will start from -1 and go until 3. This is the general form of the convolution sum in order to find out the output sequence. Okay, let's solve it now. We will do it in a different way than the previous example. It can be done like that also, but just in order to demonstrate another way, we are doing it in a different way. That in the previous one we flipped x and then shifted it towards right. Now in this example we will not flip it, we will just shift it over the values of k. Means we have from -1 until 3, so we will shift it -1 until 3. Means we are going to shift it only 5 times. Sorry, -1, 0, 1, 2 and 3. Right, so we are going to shift it 5 times, but the first value, since it is negative, it will be shifted towards left, and then for rest of the 4 values, those will be 4 values of k, the x will be shifted towards right. Okay, so first we will lay down our values like this. Values of n that will be later be used for the samples of y and the output. So how many these should be? We can calculate these values by adding the number of samples in h with the number of samples in x -1. So these are 5 plus 4, 9 minus 1 means how many? 8. 1, 2, 3, 4, 5, 6, 7 and 8 values are these. So first n minus -1, because n minus -1 will be n plus 1, means it will be shifted towards left. And then second one, k is 0, n minus 0, n means it is at its normal position. Then for the next one, it will keep shifting towards right. Okay, so from -1, 0, 1, 2 and 3 we have covered all the values of k, -1 until 3. So we have done it. Now for the next step we have to multiply each value of hk with x n minus k, right? Means this is k x of n minus minus 1, this one, right? The first, for the first value of k we will multiply it with h of -1, because this is for the value k value of -1. So h minus 1 and x n plus 1, right? So for the first one is -2 here. So this, the whole term, this whole sequence will be multiplied with -2 and laid down here. So when we multiply it with -2, this first value, it gives us 2, -6, 2 and 4, right? So similarly we go to the next value of k, which will be 0, means h of 0, the second one. We multiply it with the second, because this is the one which corresponds with k is k of 0. This is k minus 1, this is k 0. So we multiply this whole sequence with this term, this sample 2. So it gives us 2, 6, -2 and 4. So similarly we will do for rest of the 3 also, like this. Okay, so we are multiplying each term with the full sequence of x. So for finding out the final output, we will add the terms on the corresponding samples for this part only, the part where we have started to multiply, right? So there we consider that these empty cells are filled with zeros. So 2 plus 0 plus 0 plus 0 plus 0 will give us 2. Then -2 plus -6 plus -2 will give us -8, and this will give us 8, and this will give us 2 plus 1 3, and so on. So this is how we can fill our sequence here, just adding the terms in this one. Okay, and our output sequence will be written like this. So you can do convolution sum, you can perform convolution sum either through this method or the previous one that I showed. It's up to you, whichever you find easier or convenient for you. We have one more method to discuss. In this example, you have to find out the convolution of h and x, again as before, but the sequences are different now, when n is starting from 0 and ending at 3, right? So here h has 3 values, but n is 4. We can assume that the fourth sample in this sequence is 0 in order to make the length equal to xn. So it will be 0, 1, 2, it is 0, 1, 2 and 3. Now and at the end you have to sketch all these signals also. Since these are discrete time sequences and we have to find out the convolution of these two, we will use convolution sum. Okay, and this is a standard form of writing it. In this example, we are you can do this example in one of the two ways we discussed before, but here I am going to discuss another method which is most convenient for manual calculation. In order to do that, we will draw a table like this, and the top we can write the sample numbers. This is the position of the samples, position number 0, 1, 2 and 3. Then we will fill these according to the sample position in the sequences. So first, on the top row here, in the first row we will write values of x, this one xn, and in the first column we will write the values of hn, like this. So 1, 2, 2 and 1. Okay, and on the vertical one here we will write the values of x, 1, 2 and 1. Now what we are going to do, we will multiply them one by one. So 1 times 1 1, 1 times 2 2, 1 times 2 2 and 1 times 1 1, like this. Okay, then we will do the same thing. We multiply 2 with all of these and we get 2, 4, 4 and 2. Then for the last sample in the sequence we multiply with all of them and we get this. Now we are done with multiplications. We will draw diagonal lines now like this. Okay, now we are going to add all the numbers which come in between these sequences, in between these diagonal dotted lines. So this one will give us one element, two, the first point in the y sequence. So it will, adding these two will give us the second point in the y sequence, third, fourth, fifth and sixth. But how many number of points should we have? You will calculate by the number of points in h and number of points in x. You will see, first we calculate. So by adding there is only one, we will get 1. Now we will add these two, we will get 4. Then we add these 3. 2 plus 4 plus 2 gives us, it should have been 8 actually. It should have been 8 here. 2 plus 4, 6 plus 2, 8. Okay. And then 2 plus 4 plus 1, it gives us 7. And then 2 plus 2 gives us 4 and 1 at the end, right? So we have 1, 2, 3, 4, 5 and 6 samples in the output sequence. So how many number of points should be there? 4 plus 3 minus 1. 4 in x, 3 in h minus 1. So n plus m minus 1 equals to 6. So we have 1, 2, 3, 4, 5 and 6. Therefore we can write our output sequence like this. Okay, we have calculated our output sequence. Now we have to sketch all of them. So how to sketch? Very simple, like we saw in the previous example. We will use the same thing. X-axis will have the number of samples or the sample positions, and y-axis will give us the magnitude of each sample like this. So this is our sketch of our input sequence, this is the sketch of our impulse response, and our output sequence can be plotted. Our output sequence can be plotted like this. Determine the convolution of two sequences xn and hn. This is also discrete time sequence, and you have to perform it in one of the ways that you have seen before. It's up to you how you would like to do it. Just notice that this arrow shows the sample at position 0. So here it is 0, this one is at -1, -2 and -3. This is 0 and this is -1. Okay, so you have to consider this while performing any of the previous procedures that we have used to calculate our convolution sum. Okay, and this is an exercise for you. You have to do it yourself. Now the last example. In this example you are given a moving average system. Moving average system means that the system takes a few samples, then go to the next one, then take a few samples, then another one, take a few samples, and keep on finding average of those samples. In this specific moving average, it takes 3 samples, 3 consecutive samples, and find their average. So what are those samples? This is the first sample, n, then a sample before this and a sample before that. Then get the add them and divide by 3 to get average of 3 samples, right? So first sample, a sample before that, and sample before that. Means if it is 0 or if it is 1, this will be the sample number 0, this will be sample number -1. If this is sample number 0, this is sample number this will be sample number -1, and this will be sample number -2. So it is doing an average like that, and it has 4 parts. In first you have to calculate its impulse response, then you have to calculate its output when the input is the unit step function, un is unit step function, and you have to find its output when the input is like this. It is a cos of this times the unit step function. You have to determine the values of a and n. The value of a, this is the value, this is a means the amplitude of cos, and n, this is n, the total number of samples, so that the steady state response of the system is 0. Means that you have to find the values of a and n. N is also the period of, because this is sinusoidal or a periodic function, n represents its period for the fundamental period of one cycle, and we have to find these values when the response, the steady state response of the system is 0. Means that the steady state response means a stable response. The system will give us an output which is stable at 0 value. It will remain 0 for really long time. Then the fourth one, we have to use MATLAB to verify our results. Let's start our solution. First we have to find impulse response, and we know that for finding out impulse response our input should be a delta function, right? Means xn is delta function like this, and you have seen what delta function is, right? It has its sample number 0 is at amplitude 1 and all other samples are at amplitude of 0, right? So the output will be the impulse response. We replace all of these x, because this is the input, with delta. Okay, so delta n minus 1 plus delta n minus 2. So we start with our sample number 0 when n is equal to 0. When n is equal to 0, this is 0, delta of 0, then delta of minus 1, and then delta of minus 2. So we know that the delta function at sample number 0 has a value of 1, and for minus 1 it has 0, and for minus 2 it has 0 also, because it will be 0 for all samples other than the sample at position 0 or n is equal to 0. So when we calculate average, we get h0 will be equal to 1 over 3. Now we move to next, n is equal to 1. For n is equal to 1, this will be delta function of first sample of delta function. This will be delta of 0, and this will be delta of minus 1, because we are putting n is equal to 1. So n1, this will be 1 minus 1 0, this will be 1 minus 2 minus 1, right? So this sample will be 0, this sample, because it was delta of 0, it will be 1, and 0 equals to 3. And for n is equal to 2, this will be delta of 2, this will be delta of 1, and this will be delta of 0. So other than delta of 0, all the samples are 0, right? So we will get 1 over 3 again, and after this for all we will get 0. Why? Because none of these after n is equal to 2 contains delta of 0. So delta of 0 remains at 1 and all others are at 0. So therefore our output or the impulse response of this system will be 1 over 3 for n is equal to 0, 1 and 2, and it will be 0 for all other samples. Okay, now we have to find the response of the same moving averager when the input is a unit step function. Here it is given the unit step function looks like this in discrete time form, that all the samples before 0 or on the negative side are 0, and after means starting from 0 onwards all the sample have a value of or the amplitude of 1. Okay, so our input is now un or unit step function. So we use this equation or this formula again. This is the function of the output. So instead of x, we will replace x with unit step function, right? So now we'll start with 0 and keep on moving to the next samples in order to find out the average of each combination of the samples that this system performs. Okay, for n is equal to 0, this will be u0, means this one, it is 1, and then n minus 1 means 0 minus 1 is this sample, and then n minus 2 is this sample, because n is 0, so n 0 minus 1 is minus 1, and 0 minus 2 is minus 2. So this sample, this system is averaging this sample, and this sample. So it takes the values of these three samples and find their average. So the value of first one, or u0, is 1, and u minus 1 is 0, and u minus 2 is also 0. Therefore, as we have written here, then for u0 is 1, u minus 1 is 0, and u minus 2 is also 0. So the output will be the first of this step, or this sequence, this sample in the sequence will be equal to minus 1. So y of 0 will be 1 over 3. Now for the next value of n is equal to 1. We'll do the same. N is equal to 1 means u of 1, this sample, right? U of 1, and this will be equal to u of 0, and this will be equal to u of minus 1. So it will be this sample, this sample, and this sample, 1, 0, and minus 1. Sample number 1, sample at position 0, and sample at position of minus 1. We solve it, we get 2 over 3. So for n is equal to 1, our output will be equal to 2 over 3. Then for n is equal to 3, or for all n is equal means larger than 1. So when we go to 2, it will be 1 plus 1 plus 1 divided by 3, it will be equal to 1. And if you go towards the 3 or 4, let's see, for 3, it will be u of 3, u of 2, and u of 1. So the magnitude is 1, 1, and 1. Plus 1 plus 1 plus 1 will be 3, and divided by 3 will get 1. So because after this all samples have same value, means all samples are equal to 1. So for all values of n larger than and equal to 2, the output value will be 1. So it will start with 1 over 3, then 2 over 3, and then 1. Then it will keep on steady form. Okay, in this example, in this part of the example, the third part, we were asked to find out the value of value of a and value of n when the steady state response of the system is 0. Steady state response means that the response that is stable, it stays like that, means it does not fluctuate up or down. Okay, because when you know that when we switch on means when you turn on a switch, there can be a short spike, or means any transition until the signal builds up or comes down to its normal stable state. So here we have to find the values of n and 2 when the steady state of that system is 0, means the output stays 0 for a really long time. It is considered as steady state of that system. Okay, so this is the input as we are given, and we know that this is the fundamental period, and this a is the amplitude, and this n is the sample. So we have to consider these such values for which the output is 0, and the output is is average of 3 points, and this is a cost function, a cycle up and down. The half cycle is positive, half cycle is negative. So if we take the average, numerical average of all the samples, in one period of the cos or sine, that will be equal to 0, right? Because half cycle is positive and half cycle is negative in one period or one fundamental period. So the average of one cycle or one fundamental period is equal to 0. So it does not matter what a is. So we will assume that a has real number values, acquire any real number value, and n here, this is important, we can see because it is taking the average of 3 numbers only, and we know that the average of all the values in one period of cos is 0, right? And we want 0. Therefore, we consider that n is equal to 3, so that when we take average of 3 values in cosine, it gives us 0, because the average of one cycle of cos is 0. This should be equal to one cycle if we want its answer to be 0. Okay, so we take let n equals to 3 and a can acquire any value because amplitude does not matter. Then local average of 3 points will be equal to 0, because what do we mean by local? It is considering 3 points only, right? And we have assumed that 3 points is actually the cycle of cos, okay, fundamental period. So after 3 points it will repeat itself again, and it will keep giving us the average that will result in 0 value. So the value of a can be any real number, and n has to be 3 in order to get our steady state response of the system equal to 0. Okay, now how we can plot all of these in order to check if our results are correct or not. We can use MATLAB. Actually, we are required to use MATLAB as given in the question. So this is a very simple code to find out if our answer is correct or not. So first we have to define the input. So x represent input. This is the first input, this is the second input. So first input we call the first input means that was in our part number B, that is a unit step function, right? And part C was given second input, that was cosine, right? So x1, the first input is 1 0 0. We are considering first 2 points to be 0, and our actual function is starting from here. Okay, our actual signal is starting from here. This is ones. Ones means that all ones starting from sample number 1 until sample number 20. It consists of 1 row and 20 columns. Okay, this is a matrix. So once this one will generate 1 row and 20 columns. So 1 1 1 20 times. Before this, all zeros. Okay, and our total, this n is actually the x-axis of the plot, where it will start from -2 until 19, right? So it means that it has 22 points. 0 until 19, 20, and -1, -2, 22 points. These two are the padded zeros you can consider. So then sample number 2, this was this was input number 1, this was input number 2 from part C. So this is we just replace this one with this one, because that was unit step function. We needed all ones after 0, right? So this is 0 0 and then all ones from 0 until from 1 until 20. So 20 points of 1. Now from here, this is cos 2 of pi n1. This is n1, because we have 20 points here, we should have 20 points here also. So n1 is equal to, it starts from 0 until 19, means it contains 20 points here. So this one is to fill in here. and n, as we assumed in the last part, that n has to be 3, right? And this is our impulse response, and by using this formula we will find out if our answer is correct or not. So y is equal to convolution. This is a function for performing convolution between the first input and this impulse response. This impulse response was obtained in part A, right? So you can go back and see what was that, 1 over 3 times all ones. All ones means from one row and 3 columns. So 1, 1 and 1, right? And next y1, this is the output. Okay, so y1 is the output corresponding to our inputs. So this one actually giving us the length of y1. The length is y1 until the length of n. What is n? This one, -2 until 19. Okay, this is the and then this is our output for x2. This one was for our first input, this is for our second input x2, and convolution between x2 and h. Input with impulse response, input with impulse response, and this one will give us its output. Okay, after that you have to make plots between x1 and n x2. This is x1 versus n, x2 versus n, y1 versus n, and y2 versus n, and you will get the plots that you can visualize your results. If you have any questions, we can discuss later on in our live session, and also on Kaizala as well. Thank you very much.